Welcome to Electronic Devices and Circuits Lab. In this video, we are going to conduct another experiment, and the objective of this experiment is to measure the OPAMP parameters such as common mode gain, differential mode gain, and common mode rejection ratio. So how to obtain these parameters practically, that we have to learn in this particular video. So let's begin this discussion. So normally in any operational amplifier, normally the output of the operational amplifier is given by this particular expressions that you can see, which is written in the red. V output will be given equals to AD multiplied with VD plus AC multiplied with the VC. So you can find this particular expression in several books. So here you can take this particular book, which is Robert L. Boylston book. Okay, so here you can see this V output of operational amplifier is given by this particular expression. So what are these parameters AD, VD, AC, and VC? So this VD is the difference voltage that we are giving as the input to the operational amplifier. VC is the common mode voltage, and AD is the differential gain of the amplifier, and AC is the common mode gain of the amplifier. So normally, whenever we give input to the operational amplifier, then this output will be actually depending on both this all four parameters. Okay. So normally, what is this common mode signal? So the common mode signal will be given by this particular expression, VC equals to 1 by 2, V input 1 plus V input 2. As we know that there are two different input pins normally in the operational amplifier. So these are the corresponding input voltages. Okay, V input 1 and V input 2. Similarly, what about this VC, this VD? This is the difference voltage. And normally this difference voltage is given by this particular expression. Here you can see this expression. So this expression is ED equals to VI1 minus VI2. So first of all, how to conduct this experiment so that we will be able to practically find out this common mode rejection ratio. So normally this common mode rejection ratio is actually given by this particular expression AD by AC. Okay, so that you can also see in this book, right? So it is given here. You can see this. Okay, AD upon AC, that will be the ratio of common mode rejection ratio upon AC. So this is our common mode rejection ratio formula. Even we can also calculate the common mode rejection ratio in dB. So that formula is 20 log 10 AD by AC. So this way we can calculate the CMRR theoretically. Now we have to see how it can be calculated practically if we wish to perform the experiment. So first of all, to get this CMRR practically, or to find out AD and AC practically, we have to implement one circuit. Okay, so first we have to implement this difference amplifier. Okay, this is the circuit for difference amplifier. Here you can see this is our OPAMP. Okay, this is your inverting terminal, and this is your non-inverting terminal. So here we have to take few resistances. Here you can see this is R1, R2, this is R3 and R4. We have to take these resistances and we have to make this difference amplifier first. Okay. Then we have to apply one input to this particular terminal VI1 and another input to this particular terminal VI2. And then we have to see this output. While designing a difference amplifier for performing this particular experiment, you have to take a few conditions. Okay. The ratio of these two resistances R1 by R2 should be equals to R3 by R4. Okay, that we have to take care while designing this differential amplifier. Okay, this difference amplifier. So here you can see this conditions which is written over here. Okay, you can see this condition, right? This R4 upon R3 equals to R2 upon R1. This particular ratio we have to take as equal. Okay. So you please try to find it out. What will be the V output expression, right? What will be the V output expression if we considering that particular condition, right? So here I will be just showing you, it is given in the book, what will be the V output expression. So this V output expression, if you see, this is the V output expression that we are going to get, right? While applying that particular condition that R2 upon R1 will be equals to R4 upon R3. So that ratio, if you substitute, you will be getting V output that will be equals to R2 upon R1, VI2 minus VI1. Because it is a differential difference amplifier, obviously, the difference at the input that we have applied, that is going to be amplified by the this particular OPAMP, right? And here directly you can see this AD, okay, this differential gain AD, that will be given by R2 upon R1. So now let's try to see how to implement the same circuit, okay, and how to measure this parameters, right? So I have implemented this circuit onto the MultiSim. Here you can see I have taken this 7-4 OPAMP, okay, 7-4 OPAMP, right? 741 IC, okay. So it is having total 8-pin IC, okay. So here I have taken this IC. This is the inverting terminal, and this is your non-inverting terminal, right? And this is R1, R2, this is R3 and R4. For simplicity, what I did is I have taken all this resistance values equals to 1 kilo ohm. Okay, it will be satisfying that condition also, because R2 divided by R1 is equals to R4 divided by R3. And here you can directly see what will be the expression for V output. Here the expression for the V output, if you calculate from this means if you solve this circuit, you will be getting V output equals to R2 upon R1, okay? And because R2 is 1 kilo ohm and R1 is also 1 kilo ohm, this will become 1, right? So V output is directly equals to the difference input signal that we applied to this particular terminal. So here you can see that this will be whatever the input that we will be applying at this particular terminal, this will be becoming VI2 and this will become our VI1. So this way we have to apply the signals, and then we have to see this particular output. And we have to correlate this particular output with respect to this particular expression, okay? The expression that I have just shown you, this V output is also given by this particular expression, which is AD into VD plus AC into VC, where VD is the difference signal given by V1 minus V2, and VC is equals to V1 plus V2 divided by 2. Okay, so here you can see in this formula, what I did is I have taken this particular input, I am calling it as V1, okay, this non-inverting terminal, right? So for this particular input, where I'm calling it as V1, and this is I'm calling it as V2, right? So now, first of all, what we do is first we have to apply this difference signal, right? So we have to apply this difference signal. So what I will be doing is I will be taking this V1 is equals to 0.5 and V2 equals to minus 0.5. Okay, so why we are taking 0.5 and minus 0.5? I will be just explaining. Just let me first change this values. Okay, so this value is I have to take 0.5, and then I have to make this value equals to minus 0.5. Okay, let me make it 0. So now you just to make this connection, right? First we have to make this connection, and please remember, don't forget to connect this power supplies. Okay, with the pin number 4, we have to connect this minus 12 volt supply. Even you can connect minus 15 volt. Okay, no issues. So I have connected minus 12 volt, and here you can connect plus 12 volt, right? So this way we have to make our connection. Then here you can see I have connected, this is minus 0.5 and this is 0.5. So first of all, we have to see what will be the difference signal and what will be the common mode signal, because this is V1, this is V2, right? So here you can see this particular Excel sheet. You can see this VD, this difference signal will be V1 minus V2, right? And this V1 that I have applied is 0.5, okay? And this V2 I have applied as minus 0.5. So if you calculate this difference, this 0.5 minus 0.5 will become 1 volt, right? So this VD is actually becoming 1 volt, that you can see, difference signal, right? Difference voltage that we have applied is 1 volt, right? And please remember here, this is this particular voltage is V1, okay? Here it is written V2, but it is V1, right? And this voltage I'm calling it as V2, right? So this way the difference will become 1 volt. Now one interesting point is that, because what we want to calculate is, first we have to calculate the this AD, right? This AD means differential gain, and then we have to calculate what will be this common mode gain, right? So actually, this is our objective, is to find out common mode gain and differential mode gain. And then from there, we have to calculate the CMRR, right? So here you can see when V1 and minus V2 is equals to 1 volt difference signal. At the same time, what happened to this common mode signal? Okay, here you can see this common mode signal is given equals to this formula V1 plus V2 divided by 2. So if you calculate this average value of 0.5 and minus 0.5, this will come out as 0. Okay, you can substitute 0.5 minus 0.5 divided by 2, so it will become 0. So here you can see this difference signal is 1 volt and the common mode signal is 0 volt. So obviously when this VC is equals to 0, whatever be the output which is we are going to get is only because of this differential gain. Okay, because of only this difference signal, and the corresponding gain will become AD. Okay, so V output divided by the VD will become the differential gain. So that we have to remember. So here we can see we can execute this circuit. So if we execute this circuit, okay, then here you can see this V output, right? This is the V output. This voltage is 1 volt, right? So right now this VDC is coming out as 1 volt, fine. So this output is 1 volt when we have applied this difference signal, right? So here I have tabulated this result. This V output is equals to 1 volt. So now what will be this differential gain AD? This differential gain AD will be equals to V output divided by VD, right? Because VC is already 0. So this output is only corresponding to this VD and AD, right? So V output upon VD. You can calculate this ratio. So if you calculate this ratio, this VD, V output divided by this VD, this ratio will become 1. So now this one is your differential gain. Fine. So we have already calculated the differential gain, right? So what you have to do, you have to make this circuit, you have to apply this particular input signals, and then you have to measure the output, and whatever be the output that you have to tabulate, and then you have to divide this V output with respect to your difference signal. That will be giving you the AD, right? So that we have already calculated. Now we have to apply a common mode signal, right? So here you can see this common mode signal. We have to apply this common mode signal such a way that this difference signal should become 0. Okay. So if we take 1 and 1 volt, right? 1 and 1 volt. So let me make it 1 and 1 volt. So let me disconnect this one. Okay. So first we have to stop it and then just disconnect this one, and then you can make a connection, right? In this way, right? So now we have to make it 1 volt. So now I am making it 1 volt. So here you can see this because both the input signals V1 and V2 is now 1 volt. So 1 minus 1 will be giving you difference signal will be equals to 0. So that I have written over here. Here you can see this difference signal will be 0. Now what happened to this common mode signal? So this common mode signal is nothing but V1 plus V2 divided by 2. Okay, it is the average value. So 1 plus 1 becomes 2. 2 divided by 2, it will be 1. So this common mode signal, now here you can see this 1 volt, right? So you please observe that when we have applied the difference signal, right? At that time, this common mode signal was 0, right? When we have applied the common mode signal, this difference signal was 0. That we have to ensure first, right? Then you can execute the circuit. So once you will execute this circuit, you will be able to see what is the output, right? This output is coming out as 2.05 millivolt. Okay. And what we are supposed to get, we were supposed to get this value should be 0 because it is a difference amplifier, right? So normally in the practical op-amps, you won't find such cases, right? Whenever you are applying a common mode signal, this output is not going to be 0. It is giving a certain output, okay? And therefore, we are interested in to know what should be the CMRR value, common mode rejection ratio, okay? Ideally, this value should be 0, right? It should be 0, but it is not coming out as 0. So this value is 2.05 millivolt that you have to note down here. So here I have noted down this particular value output. V output is coming out as 2.05 millivolt. So now, again, you have to follow this particular expression because V output is coming out as 2.05 millivolt and difference signal is 0. So this expression will become V output equals to AC into VC. And we know that VC is equals to 1 volt. So this V output directly will become the common mode gain AC. So here I have calculated this common mode gain AC 0.00205. Now I can follow this particular formula to find out this CMRR. It is AD by AC. So if you please calculate this ratio, this AD by AC, this is 1 and this is your AC. So if you calculate this ratio, you will be getting the CMRR absolute value that will be equals to 487.8048. And now you can calculate the same CMRR in the dB. Okay, so I have calculated same in the dB. So I hope you must be able to understand how to calculate this common mode gain, difference mode gain, and CMRR practically. So please try to implement the same circuit onto the breadboard. I hope you must be able to perform this particular experiment. So thank you for watching this video. If you are having any query, any doubt, you will please let me know with your comments.